To Conics on Origin Part 2. Today I'm going to be talking about ellipses. So first we're going to be, basically, where do we get the formula for ellipses? We're going to be starting with that, because we don't have to talk about conic stuff this time. So we're going to start with the formula for a circle. It's x squared plus y squared equals r squared. Okay, so that's the formula of a circle, but what's an ellipse? That's an ellipse. That's not a circle, that's an oval. Ellipses are ovals, which means they have two radii. So what we're going to do is divide the whole thing by r squared. So we get x squared plus y squared both over r squared equals 1. So we're almost there. This one's actually a lot easier than the parabola one. Just because there's two radii, I'm going to name one of them A. Sorry, that's a bad. It looks like a 2. Let's just pretend that's an A plus y squared, and then the second one is going to be a B. So that's our formula for an ellipse. Remember, this is all on origin. I'm doing the off origin sometime in the near future, but like I said earlier, this is a 20-time project, and I said this in the description of a video. It's a 20-time project. It's going to end soon, so, unless you support the channel, so go ahead and leave a like if you like this video. But we have our, because that off-origin video won't happen if you don't, we have our equation for an ellipse. So now let's do stuff with it. Okay, so before we start doing anything else with the ellipse, I'm going to talk about these two pink points. So these two green points are our vertices. They're the points on the diameter. They're the main vertices because they're on the longer diameter. Then these two purple points are our co-vertices because they're the endpoints of the shorter diameter, if that makes sense. And then these pink points are the foci. And basically what a focus, because foci is plural for focus, what a focus is on an ellipse, any point on the ellipse is equidistant, has a constant distance from the two foci. So this distance plus this distance will be the same if the point was here. This distance plus this distance will be the same as this distance plus this distance, pretty much. And that's what the foci are. They're those points that make everything constant. And so, what do we call that? Well, we call it C. So here's the center, here's a focus. This distance is C, this distance is A, and this distance is B. And so, how do we find C? Like, if we don't know where the focus is, how do we find C? Well, there is an equation for that. It's very similar to the Pythagorean theorem. It's a squared minus b squared equals c squared. And let's explain. Okay, so why does a squared minus b squared equal c squared? Well, we have an ellipse here, and I labeled some stuff. I labeled all the points except this one. Yeah, that's it. I labeled all the points except that one. And I also labeled A, B, and C. That's not C. That's the name of a point. So we're gonna look at why a squared minus b squared equals c squared. So if we see B, this distance, I'm also gonna label this as C. So using the Pythagorean theorem, we can say that JC squared equals b squared plus c squared. Then we subtract b squared from both sides. JC squared not JP. JC squared minus b squared equals c squared. So if we can prove JC equals A, we can use substitution and prove that this is true. So why is JC A? Well, if we look at the definition of an ellipse, every point on it is equidistant from here to here, which would mean for this to be on the ellipse, it has to be equidistant from JC to CK. So JC plus CK, that has to be equal to, I'm going to use the bigger diameter. I'm going to say it's equal to JV plus KV. Because every point on an ellipse has to be equidistant from the foci. And yes, and these two, if we have the distance from focus 1 to point C, plus the distance from focus 2 to point C, focus 2, equals the distance from focus 1 to point V, plus the distance from focus 2 to point V. So now let's substitute a few things. So CK, this line right here, well, because both of them equal b squared plus c squared, because I could have used this triangle right here for the Pythagorean theorem instead of using this triangle right here. So they're obviously equal because they both equal b squared plus c squared. So I'm going to just say JC, because that's what we're trying to prove, JC plus JC, and I just substituted. We can rewrite that as 2JC equals JV plus KV. So now we have to connect this whole thing to A. It's not connected to A yet. Well, JV, this distance right here, plus KV, why is that a 4? KV, this distance right here. Well, isn't JV equal to KL, this distance right here? Because the two foci are equidistant from the center. So I would say yes, because the two radii are the same length, because the two A values are the same and the two C values are the same. So I'm going to say JV plus JL, because KV and JL are the same. Or you can think of me saying JL plus, JL plus JV. Either one. 2JC equals JV plus JL. And JV plus JL, isn't that just 2A? Because half of the diameter, the bigger diameter, is A. So the whole bigger diameter is 2A. So we have 2JC equals 2A. Divide the whole thing by 2. JC equals A. And so that's why A squared minus B squared equals C squared. Let's write a happy face, because I'm happy that I did that. Okay, so now I'm going to talk about a few things that are important, but I really couldn't talk about them in their own segment. And I'm going to do a few graphs. So this at the top is just like agenda stuff for me, so I don't forget what I have to do. So first thing we're talking about is this C over A right here. We know what C is, we know what A is, but what does this mean? So a way to measure the ovalness, I guess, of an ellipse is by doing this C over A. And if we look at an ellipse, the focus, we can't really see the focus if we just look at this ellipse. Like, we can see A is right there, or A is right here, I guess, this distance. We can see this distance is B. We can see that, but we can't see the distance between C. We need a point that's focus, or we need the equation where we can find the focus. So, to measure basically the ovalness of any oval, or an ellipse, because this is more ovalish than this. And I will promise you that this one has a higher C value. This one has a higher C value than this one. And so basically, the best way to measure ovalness is with this formula, E, eccentricity, equals C, the distance from the vertex to the focus, over A, the distance from the vertex to the center, the bigger vertex, and C's the distance from the vertex to the focus. It's the distance from the center to the focus. I don't know why I keep saying that. That's basically eccentricity, measuring the ovalness of an ellipse or oval, depending on what you want to call it. Clear up some room. I'm really bad at erasing, though. That's why I normally cut this out. But I'll just not make some room. Okay, so now we're gonna decide. How do we decide if it's a horizontal ellipse, like whoop, or a vertical ellipse? Whoop. So, I'll use this equation for an example. X squared over 25 plus y squared over 16 equals 1. Is that horizontal or is it vertical? Well, me, being so smart, knows that it is horizontal. But how would you know that? Well, A is always a larger value, right? So I can tell you that that's A. Actually A squared. And that's B squared. B squared! That's a 2, not a 7. That looks even worse. So we know that that's A, that's B. So how do we use that to know if it's horizontal or vertical? Well, A is always bigger, which means X has to be 5 for this to equal 1, and then Y is 0. That'll be one of the coordinates for our vertices, 5 or -5, because -5 squared is the same thing as 5 squared, so plus or minus 5, 0. That's one of our coordinates. Our other coordinate for our co-vertices, because they're smaller, are 0, plus or minus 4, because that plus or minus 4 makes this 1 over 1. Oh my gosh, I'm so sorry. My handwriting's really bad. And basically, how we know it's horizontal or vertical, how we tell if it's horizontal or vertical by looking at it. If the bigger axis is horizontal, we're going to say the whole thing is horizontal. That ellipse is horizontal, right? This ellipse is vertical, right? You don't tell me that this ellipse is horizontal unless you mix up your horizontals and verticals. Just everyone will agree that this one's vertical if they know they're horizontals and verticals, and this one's horizontal. And so, because this is A, and it's the x coordinates, and this one in this ellipse, sorry that arrow's weird, is A, and that's the y coordinates, what we can deduce from that is if A is under the x coordinate, it'll look more like this. I mean, it could have more ovalness or eccentricity, and if the A is over the y coordinate, it'll look like this. Again, with more or less eccentricity. So I'm going to clear the board, and we're going to graph 2 equations. Time to graph. What we've all been waiting for, what all of this knowledge is building up to. So, all of these equations are on origin. That should be in the title of the video. I haven't made the title of the video yet. And so basically, from the equation, we can get 2 numbers very easily. We can get the A value, because that's A squared. I'm doing this one first, because this one right over here is weird, and we'll look at that later. This A value over here, this is A squared, which means A value is 5. This is b squared, which means b value is 4. Okay, so, and because the a value is under the x, we just talked about this, it is horizontal, which means that point's there because the radius is, the bigger radius is horizontal, and it's 5. That's what we just found out. And there's another one here, because radius is 5, it goes both ways. Same thing with b. Up 4, because it is, b is for the co-vertices, the vertices on the shorter diameter. And we can technically graph it with that. I want to find the c values so we're used to it, because a problem you might get in your textbook might ask for eccentricity. So c, a squared, 25, minus b squared, 16, equals c squared. 25 minus 16 is 9. And take the square root of both sides. C equals 3. C does not equal plus or minus 3 because c is a distance, and you cannot have a negative distance. That is something I learned in geometry. I pretty much already knew that. So, c, distance from the center to the focus, 1, 2, 3. And it's always on the bigger axis, 1, 2, 3. Now we don't technically need that for the graph, unless we wanted to talk about focal width. And I might talk about that. Actually, I'll talk about that now. That's the equation for focal width. I could show you a proof, but I feel like this video is getting too long. Your attention span is probably going down. But we plug in numbers to there, and we get the focal width. So I'm actually going to go ahead and do that just because I want more points so that this ellipse looks good, because my handwriting's already really bad. 2 times b squared, well, b is 4, and b squared is right here. I don't only have to do any work. B squared is 16. 2 times 16 is 32. A is 25. So, I mean, no, that's a squared. Sorry, that's not a squared, that's a. A is 5. Got that right there. 32 over 5 is 6.4. That's pretty nice. So, 6.4, that's the whole focal width, not just one side of the focal width. So 64 divided by 2, 3.2, that's one side of the focal width. So 1, 2, 3, 2. That focal width is the distance from the focus to a point on the ellipse above or below the focus, pretty much. 0.2, 0.2, 0.2. And our focal width should form a nice box. I wouldn't really call that a yeah, no, not a square. And then we have our ellipse. That's just this equation. Time to get graphing this equation over here. Now, like I said earlier, that equation is weird. We don't like it. We're going to divide the whole thing by 400, because if you remember the standard equation, it has an equals 1 to the right of it. And I'm not going to rewrite the whole thing because I'm too lazy. Also, x squared and y squared are under something, and that's not. So let's just divide the whole thing by 400 and see how it turns out. Well, we end up getting 25 x squared over 400 plus 16 y squared over 400 equals 1. I see some fractions that can be reduced. 25 over 400, 25x squared over 400, can be actually reduced to 1x squared, which is x squared over 16. And 16y squared over 400 can be reduced to y squared over 25. 1y squared over 25. Those numbers seem familiar. I'm pretty sure I switched them around from here on purpose. And every problem I've gotten in my textbook has done pretty much that. And so now, graphing is almost exactly the same. If you notice, there's one difference though. Our focal width is the same because our A value and B value are the same. There's one difference. Write down focal width on each side. The A value is under the Y coordinate, which will make, and I just like not having to erase everything. Sorry. I'm sorry if this bothers you that I'm doing this on the same graph. I truly am. And basically that's just because distance from center to co-vertice 4, that's B, center from vertex A, that's 5, and then horizontal and vertical stuff. We got that, and that's how we know A is up and down. Okay, and then focus, it's going to be 3 again because our A and B values are the same, but this time it's up and down because A is up and down. And oh my gosh, this looks so bad. I'm sorry that I'm exposing you to this. It's my laziness. It's my fault. 3.2, once again, focal width. Oh, whoa. Yeah, I totally messed this graph up with the where I place the lines. I'm not very good at that. That's not one of my skills, really. I mean, I don't need it badly to be good at this subject, but it helps. Wait. I forgot where I was. Okay, and you go there. Oh my gosh, my handwriting's so bad. I'm so sorry, guys. Something like that. Obviously, that's not right because my handwriting's so bad, but yeah, that's not right because this is the A value. Like I said, I'm so sorry I put 2 on one graph. I just wanted you to show you that A and B and C are the same. It's just flipped. That was not a good idea, though. I mean, the shape's pretty cool. So I think that'll about wrap it up. If you want to see more, definitely like and subscribe. Like, the last video I did has no views as of now. I'm not very happy about it. And I know in the description of it, if you saw it, which no one has right now, but if you saw it before you're watching this, I said that this is a 20-time project and I do need likes to get encouragement to keep doing this after it's done. And when it's almost done, it's done like in 3 weeks, so that's only 3 more videos. So you better like and subscribe. Also, I realized that I didn't post a video last week. I'm posting 2 this week to make up for it. I'm so sorry. My laziness kicked in last week and my inability to find time to record. But that'll about do it for this video. If you enjoyed, please hit that math boy cannot do handwriting subscribe button. Leave a like. See you in the next video. Bye, math.